Welcome back, everybody. In today's video, we're going to look at how to predict the amount of tip that would be given at a restaurant using the tips dataset. Now, in this, we're going to look at a couple of regression models that we could actually use to solve this problem. And so we're just going to take it one by one and see which one works best. So for starters, we have the data here. It's the tips dataset. Now let's look at the head of this dataset. We can do head. Okay, so what we see here is for each row, we have information on the total bill. We have information on the amounts of tip. We have information on, the person that made the payment, whether it's a male or female. We have information on whether the person is a smoker or a non-smoker. We have information on the day of the week, the time of the day, and also the size of the group. So was it two people that ate together? Was it a bigger group, or was it one person? So the first thing you do is once you import your data set, you want to see if there are any missing values in the data set. And to do that, there are a bunch of ways we can do it. I'm currently using this helpful library called Datamallet, and you can actually install it using pip install Datamallet. The current version is 0.19.0. And so to do this, we're just going to go ahead and use this function. Of course, there are different ways you can do it, but I feel this approach tends to be very fast in general. So we'll use this function called %missing. We'll pass in the data frame and we do this. So you can see for each of them, there is 0% missing data. So that means there is no missing data at all in these data sets, which is good. Very, very good to know that. Another very important help function, which I tend to use, is extract column types, right? So here you can extract the column type of each data set in a pandas data frame. So let's just say column, let's give it a name. Now, if we just do this, now we can see we have object columns as sex, smoker, day, and time, which of course we can see here because they all contain texts. For numeric columns, we have total bill, tip, and size. So next we'll do is we'll go ahead and just do some basic EDA. So let's just say exploratory data analysis, right? We ask ourselves a bunch of questions to see what could influence the amount of tip given. So the first thing we should do is let's see the distribution of the tips. Okay, so distribution in this data set. And so for that, for me, I tend to use Plotly Express or Plotly for my visualization, and I've actually imported it here. Okay, so with that being said, we'll go ahead and just use Plotly. So we can say let plot, we're going to use the histogram function. Could also look at it as a box function as well. Let's do it as an histogram first. So data frame, let's call it df. Next, would look at what we want on our x-axis, and this case is called tip. Okay, so just provide the column name as a string, and there are other things you can actually specify. Let me show you here. For histograms, you can specify the facet row, facet column, a whole bunch of stuff. But for now, we can also include the marginal. Let's go ahead and just make, let's say we want a box on the margin as the marginal. Okay, we need to call the show method. Okay, and there you have it. this is what the distribution of tips actually look like. We can see here that the median value of the tip is 2.9. So let's assume this is dollars. $2.9 or $2.90, right? We can see here that the upper fence is actually 5.992, so $5.92. And you can see that these points are actually outlier points. These are points that they just don't fit the rest of the data. Like, they are really, really excessive. So we could, let's say like this point here, we could find out, okay, what is going on at this extreme point. Okay, so let's find this. In this case, the tip was $10. So we could say, okay, where did the $10 tip come from? So to do that, we could easily just do this. Let's just see where is we can say where is greater than or equals to, what was this last one? 9. Okay, we're going to index this way, and to the frame. Okay, so these are the 2 points where we had, such huge tips. Okay, there was one time a tip of $10, then a tip of $9. It was both on a Saturday, and it was for dinner, and it was a sort of large group, and they spent, $50, and this other person spent $48. So this looks really huge, right? Now, when it comes to dealing with outliers, depending on, your project, you could choose to, it's always a good idea to remove outliers, but, in this case, it's just, simple demonstration, and we could just leave them there, even though we know for sure that, yeah, it's quite a bit. In this case as well, we have very high amounts of tip, but these are like very extreme levels. We know they exist. I'd say for this pass, in your project, like if, you have enough data, you can definitely just clip the outliers and just, put them at a particular maximum point. But in this case, we're just going to go ahead and just leave it there, and then we can always come back and revisit it. Good. So we know that this is what the distribution looks like for the tip, right? Now we can go ahead and investigate, okay, what are the things that can actually affect the tip, right? So what are things that can make the tip become more or become less? Okay, so for that, let's just do a bunch of scatter plots. And to create that, we can go ahead and use a helper function from Datamallet to do that. For this, I'm going to use this create scatter function. So column types, I believe that's what I called it previously. Okay, put S there. So let's put S. Here we can specify, okay, create HTML equals to false. We don't want to do that. Let's include maximum color groups as 5. Okay, that's fine. Okay, so this is what we're going to do here. Now, what this helper function helps us to do is it helps to create, a whole bunch of plots with a few lines of code. And now we can iterate through this list here. And what you have here is a list of Panda Plotly graph objects. Okay, so we could just do for figure in this, we call fig.show. And so here, what we can see is, there is a kind of linear relationship between the total build and the tips, which is great. There is, here we're coloring it by the sex, here we're coloring it by the smoker. Here we're coming by the time, by the day, whether it's a Friday, Saturday, Sunday, or Thursday. Apparently this restaurant is not open Monday to Wednesday. Here we're looking at it, with respect to time as well. And what you'd see is that, the relationship is pretty much linear in both cases, in all cases. What the color just shows you is just a different dimension for you to see what effect you have here. So now here we're looking at, okay, what's the relationship between total bill versus size? Okay, so you can see that the size is pretty much, how do I put it? It takes a fixed number of, at least in this case, the highest cases of when we had 6 people, and of course we have cases when there's 1 person. And so it just follows that pattern pretty much all the way there, right? We can scroll down some more. We can decide to look at, okay, what effect does the size of the group have on the tip, right? So this is the tip, and this is the size of the group. You can see that it's hard to say, like, for example, I could look at, okay, for a particular tip of, let's say, $5, I can have the same $5 tip, whether it's for 4 people or 6 people. So this doesn't show me anything strong in particular. Like, I don't see any strong relationship between, the size of the group and the tip. Okay. Same here. Okay. So we've done that quick analysis. Now, I guess we now have to ask ourselves, right? What else do we think can affect the amount of tip? Okay, so we know here we've seen the distribution. Now we can go ahead and look at, we've already seen that, okay, the only strong relationship we can see here is that of, we can see a strong relationship with that of total bill versus tip. Okay, now let's see if that plays a role across the different facets, right? So let's do something like this. Let's plot something extra here. Okay, so plot across facets. Okay, so here we want to look at the relationship between the tip and total bill across time. So that's why we're using the facet column. And we can see here that whether it's for lunch or dinner, there still is that, positive relationship between total bill and the amount of tip given. We can copy this and decide to explore it across different other dimensions as well. Okay, now you see the same thing essentially. There is that relationship. It does seem from these data sets that, most of the male customers tend to, spend a little bit more than the female customers. And as a result, they tend to give a little more tip as well. Okay. We can look at this dimension through the lens of a smoker as well. Okay, so here you can see, pretty much the same thing. There is still that relationship. However, we can still see that, okay, smokers tend to give a little more money than non-smokers according to this data set. Cool. Okay, next, what we can do, we've, looked at different things that affect the tip on different facets, right? So we pretty much essentially separated them out. And we need to ask ourselves, okay, is there going to be a difference if, let's say in this case, we looked at the time, is there going to be a difference when we look at the day of the week? So let's say break this down by day. Okay, so what effect does that have? You can see there is still that positive relationship. Seems to me like more people come over the weekend, just in general, as against weekday. And we could decide to add color to this actually, and color it by, let's say, the gender. So the red is male, the blue is female. And so we can see there is still that relationship. So obviously, if I'm going to predict tips, I know that total bill is something I'll definitely include. Now, next, what I want to see now is, okay, what group of people tend to spend the most? Right? There are different things we can look into, right? And we can look into, let's look at the dimension of whether it's a weekday or weekend. Okay, so we've done some basic exploration now. Let's go into creating some features for this data set. Okay, and then we'll do some more plotting. Okay, so let's do feature. Okay, so we have these features. Let's say, what effect does the weekend have on the tip amount? So to do that, we need to find a way to create a column for the weekend. And so for us to be able to do that, we will need to use apply function in pandas. But first we need to create a function. Okay, let's call it weekend, that determines whether this happens on the weekend or not, right? So we can easily say, okay, if row is equals to sat or sun or row equals to sat, return 1, else return 0. Okay, so whether the day of the week is Saturday or Sunday, return 1. If not, return 0. Awesome. Okay, yeah, let's do that. Now what we can do is we'll just come and say create a new column and say day so we're trying to apply this function on this particular column, and so this is what we do. And we say, okay, weekend, right? So we have a new feature called weekend. We've created that, and we can go ahead and explore it. Let's now ask ourselves, okay, is there any other feature we would want to investigate? And we can say, okay, yes. How about the size of the group? We might want to say, okay, do we have a single person eating, or do we have more than one person eating, and what effect does that have on the size of the tip? In this case, we had looked at tip versus size, but for all the sizes. So now we'll essentially be looking at, okay, the case where it's one person versus multiple people, and we can see what effect that will have. So let's do the same thing here and say, okay, let's call it, you can call it whatever you want. Say single member. Could be anything. And for this, we can say, okay, if row is equals to if it's one person, return 1, else return 0. Okay, so if it's one person, return, single member 1. Now, if it's multiple people, if it's not 1, so it's 2, 3, 4, 5, 6, whatever it is, return, okay, 0. This is not a single member. Okay, cool. Let's now use this function. So we're going to apply it on the size column. I'm going to use the apply function, and we'll just call the name single member. And there we could say okay, so now we've created this too. Let's look at our original data set, see if if there's something else we can include here. Okay, so we have day, we've created some feature based on size, created feature based on the day of the week. We have either lunch or dinner, it's fine, smoker or non-smoker, and we have the gender here. So we're just going to go ahead and see how, these features we've created, if they have any effect at all. Okay, so let's just do more EDA. Okay, we're going to do more EDA. And for that, let's look at, total bill versus tip. We could do this here. We'll use a different facet. Okay. Could also look at distribution. So let's say single member. Okay, so a lot of people come in a group. A few people come single here. So it's kind of hard to tell in this case. So not too many, the number here is not significant. So let's look at this also under the lens of like the weekend. So you can see, we still see the same linear relationship. You have much more people coming, of course, on the weekend, spending more money and hence giving a larger tip than during the weekday. So that's interesting to know. So yeah, we can see that the relationship still exists. Now we can go ahead and ask ourselves, okay, the tip, how does it change across the different whether smoker categories of smoker versus non-smoker and things like that. So to explore that, we can just say, okay, what group of people give us, the most total tips? Okay. So now let's go ahead and just create dummy variables, right? And see what effects that would have as well. So let's say create dummy variables. Okay. Ask ourselves here. For this, we can decide to use the get dummies function in pandas. That's fine. We could also use, let me just put this here, get dummies pandas. We could also use this utility function. Let me go, and I imported it at the top here. It's gotten from Datamallet, tabular, module, and feature. And we can use this very easily to create a dummy variable. So we want to create dummy variables across time. I want to create dummy variables across gender. I want to create it across day. I want to create this as well across time, day. So we've defined that, and we can do the actual transform. So let's just give it a variable name called. Now, one-hot encoding is a very, very common approach used in a lot of machine learning problems. It's essentially just a way of converting categorical features to numeric features. So let's just do transform df. And now if I show you the shape of that before, if I do the same thing, we can see now we have 15 more, we have 15 columns as against to the 9 columns. So I could just show you what has happened here, and you see, okay, we have, okay, single member, well, of course that's been there already. So now if time, dinner, or lunch, we have this indicators. We have sex, female or male, day of the week, and smoker or non-smoker. Okay, so now that we have all of this, we've been able to create these dummy variables essentially, which is fine. Now we could decide, okay, do we want to create features for when the person is a male and a smoker as well? So there are different so we already have these features here, the one-hot encoded features, and we can decide, okay, now we want to consider some other things here. We want to see, okay, what was the, do we have a male smoker in this distribution, and how does it affect? So just giving out ideas of the kind of features we can create, but we can't spend the whole day creating features. I'd say we go ahead and, split our data into train and test and build our model. So let's just go ahead and do this. Okay. So here we're getting what our y is, and we're dropping that y from this. So we can also go ahead and say, okay, our x is equals to df1.values. Okay, so now we have our x and our y. Next, we need to go ahead and split that. Okay, now for that, we're going to use a train test split function. I know a whole bunch of us are already familiar with train test split procedure. So essentially, you need to provide what your input is as x and what your target is as y. So whether it's for classification or regression, so for supervised problems, you can give it test size. In this case, I just want to use 20% for testing. You could also use as high as 30% for testing as well. And I like to give a random state so that, everybody can have, identical results. And so now we have this. Next, what we can go ahead and do is now actually try out different models. Okay, so let's first, when I do models in machine learning, I like to start with it small and see if I can improve moving forward. Okay, so the first model we're going to do or use is, we're going to use a lasso regression. Okay, so that's available in the linear model. So we'll say linear model dot. Now for this, we want to use something called grid search and want to be able to investigate every single parameter. Well, have a set space of what parameter would work for this problem as against what other ones. So for this, we're going to now use the grid search. Okay, let's just call this our model. Let's say grid So we provide our estimator. In this case, we want it to use this lasso model. So that's what we're going to use there. Estimator is this. Next, we need to specify how much cross validation do we want. We want 5 folds, which is fine. Now, for you to use grid search, you need to also find a way of scoring your models. Okay, so we want to score the model. Since it's a regression problem, we want to score them using, we could use the mean squared error, mean absolute error. But I want to see how it performs on our R-squared value, right? So that's coefficient of seeing how much of the variance is explained by the data in the input. Okay, and we could also say we want it to be verbose. It's a level 2. Want it to have some output. Now, one very important thing here is we need to specify our parameter grid. Now, this parameter grid is expected to be a dictionary, and it's expected to have a list of values we want to investigate. So in the case of a lasso regressor, we're interested in looking at the alpha, which is a measure of the amount of regularization you're going to use. And so for that, we can specify as a key we want, okay, alpha, and the values we want this grid search to actually search through. So let's just say 0.001, 0.1. Want it to also search, this is 0.5. Want it to search 1.0. And yeah, we can just add maybe 0.3 in the middle there. Of course, the more you add here, the much more time this is going to take to run. And yeah, I feel like this is an adequate search space. We could just go ahead and do this. Okay. Next, we have this. Next, we now have to train. We have to fit it to the data. So we do xtrain, ytrain. Okay, let it run. That was really quick. Okay, so you can see it was able to go through, first of all tried, okay, alpha values 5 times, alpha values of 0.001. So that's where the K fold, the CV value goes. Then it looks at alpha values of 0.1, 0.3, 0.5. You get the drift. Now for us, what we want to do now is we want to see, okay, what is the best, estimate out of all that was searched. So now what it's telling us is that the value that gave us the best result had the alpha value of 0.5, right? So remember here we tried all of this. It was 0.5 that gave the best outcome and not the one of 1.0. So that's fine. Now we can go ahead and look at some of our predictions and some of our metrics to see what we get. So here we want to calculate the mean absolute error, mean absolute percentage error, mean squared error, and see what we get. Okay. So the first, mean absolute error. So we have a mean absolute error of 0.62. So what that means is that whatever the prediction is on average is off by 62 cents in terms of the tip. We want this number to be as low as possible. Let's see our mean absolute percentage error. So there was a 27% error on average. Now let's look at our R-squared value. Now what this shows us on our R-squared value is about 55%. So what that means is that with the data we have currently, like all the features don't perfectly explain the tip. Now, this doesn't really come as a surprise to me because most times people give tip based on a percentage of the total bill, and most times most restaurants give 15%. So that may be the reason, okay, in this case. So what we could do is there are several things we could do. We could try out, another different model here. We could also expand this. So let's say we want to consider, something in this region. Let's say we want to add, can add much more parameters here. So we have a much greater search space. Let's see. Okay, that was very fast. So let's see what our best estimator is now. You can see, it picked 0.6 because we extended the search space. Oh, but only small improvement. Now at this point, you could do several things. You could now, let's say you want to try a different kind of model. So let's say in this case, we choose to look at, Random Forest. Okay, so let's just put this here. Say 1, 2, 3. Lasso regression. Okay. Next, let's say we want to look into Random Forest regression. Okay, so for that, there's a bunch of boilerplate code we have to type. I want to save everybody's time. But before we even dig this further, what I'll quickly do is I want to get access to the weights, okay, for this result. Now we had this prior model and, we know this is the performance of the model. But now, before we try a different model, let's even see what weight was given to each of the features. So we'll say model dot best estimator. Then now, once we have the best estimator object, because we know that object is a lasso regressor, we know we have this coefficient underscore attribute. So if we call it out, this is what it is. Now, we can see that, the way lasso regression works is it tries to shrink some of those coefficients to 0. It definitely tries to do that. And so that's the case of what we're having here. It's trying to shrink everything down to 0. So let's see what this actually means in terms of the actual columns. Okay. So we could just copy all of this. PD dots data frame. And we have df1 dot columns. Okay. And want to make sure, let's see if this is in the right shape actually. Okay. Let's do. So what we can see here is every other weight is shrunk, its value is shrunken to 0. The only thing that the model looks at is the total bill. Okay, which is quite interesting if you think about it. It looks at, okay, what is the total bill? And then just uses that to determine what the tip would be. Which, if you think about it, is in line with what really happens in real life. Now, this lasso regressor does this by default, right? So it tries to bring out only the strongest features. And from what it's saying, irrespective of day of the week or time of the day, the total bill determines, what the tip would be, which, makes sense from what we know from common sense. I believe for us to be able to explain why tips are different from the other, you have to also look at other things like, okay, how friendly was the waiter? That's one feature. If it can be ranked or provided here, that would be great. What's the gender of the waiter, the person receiving the tip? Do female waiters receive more tip than male? All those other things can actually be features which can be included here. But so far so good. This is what the output of the coefficients actually looks like. Now bear in mind that in this case, I didn't do any type of standardization, which, I mean, you can do it. I think it'll be great. In this case, I just didn't do it because, we have a lot of dummy variables, zeros and one. And in this case, it's fine to not do it, but you could go ahead. We could try that out as well. See what it's going to look like if we include a standard scalar and see what the output will come to. But before then, let's investigate, random forest is supposed to be a much better model. It doesn't necessarily require scaling before you get your output. So we can definitely try it out. And then a third model, go ahead and do, your basic scaling and see what the output looks like. See if there's any improvement at all. Okay, now in this case, we have our base estimator, which is random forest regressor. We're using grid search again. So let's call this model 2. So it doesn't conflict with the other result. Once to score based on the R square, we could have changed this to the mean absolute error or the metrics. I feel like R square is just representative enough of everything. In general, if you have a much better R square, you're going to have a much better metric across the board. So in the case of random forest, there are several parameters we can supply. We can supply the number of estimators we want. We can supply the depth of the tree or forest of trees and things like that. So I chose just these 3 for us to investigate. So 5, 10, all these estimators, this max depth. Let's see if we can add some more here. Bear in mind that this is going to take much longer, of course, because random forest regressor is a more complicated regressor. It's an ensemble of decision trees as compared to just irregular linear regression. Okay. Yeah, so let's go ahead and do this. We'll say model 2.fit. Okay, now this is going to take some time. So I'm just going to pause it and come back. Okay, now we are back. It took a couple of minutes, of course, because it's, much more experiments to run here. So let's go ahead and just see what the best estimator is in this case. Let's see if the random forest in this case does any better than basic lasso regression. So we can do this. Let's call best estimator. So now we can see in this case, we had a max depth of 9 as the best pick, with a mean sample split of 0.2 and number of estimators of 30, which is okay, cool. Next, let's look at this and let's say look at the feature. Yeah, so now we've got this feature importances from the random forest model, and so we have it here. Let's look at the shape. Okay, 14. Now I want to look at df1.column. Okay, so now this is it. This is what we have. So we can see that the random forest regressor actually looks at not just the total bill, also looks at the size of the group, looks at, whether it's a weekend or not. It looks at all the other features. Yeah, we could have dropped some of all these ones as well, since we already have this engineered feature, which checks whether it's weekend or not. So in another iteration, we can definitely do that. But that being said, let's just see what this performance actually looks like, right? So we have our model 2.predict. Want to predict it based on X tests. Okay. let's put that into predictions 2. Now we can check its performance. Okay, I have all this code somewhere here. Just save us from typing too much stuff. Okay, so first let's see now we can see here that the error actually increased. Let me see if I can close this already. Now we can see that the simple regressor, linear regression model Lasso had a mean absolute error of 0.62, so even did better, was a lower error. Let's see, the percentage error is even worse in this case. And our R-square value is even way worse in this case of this random forest. So what that's telling me here is several things, right? So first of all, we need to engineer more features that have much more information than what we currently have. And looking at the days of the week, time, smoke, I didn't have a strong enough influence. However, if we decided to maybe engineer a new feature, based on those categories, then, we might get much better performance out of it. But as it currently stands, this is what we have. The better performing model is the Lasso regressor, and it has this absolute error, right? So there are much more that can be done in this for this problem statement. Now, is it good enough to stop here? It depends on your problem, right? So is an error percentage of 27% good enough for your use case? If it's yes, good. Stop here. If it's no, well, need to dig deeper. Are you okay with being off with the 62 cents on your tip or not, based on your prediction? If your answer is yeah, I'm okay with that, and that's fine. Can go ahead and just do this. But if it's different, then yeah, you definitely want to try out some other things. So I know the video is already very long here. I'm just going to stop at this point. If we ever do get back to this problem, we can now try out, creating some very exquisite type of features. We can try to see if we can improve the model performance. And then the next step is we can see if we can include this into like a Streamlit app or something like that. Okay. So what have we done so far? We've done several things, right? So we have imported some of our libraries. We've carried out exploratory analysis for the tips dataset, trying to see how we can predict the tip, the amount of tip that a waiter gets from, people in the restaurants that come visiting. And we've done some basic feature engineering, using the apply function in pandas. And there we're able to, look at, okay, is this person single? Is this person in a group? Things like that. And that's essentially what we've done, right? So I see a bunch of things that can be done. For one, we could go ahead here with the random forest and say, okay, well, since we've already created single member, we can decide to, since we've already created, let's say, weekend, we can decide to just drop this day of the week. All of this we can drop off for and see if we get something better. And just see what effects we can get, if we can get much better performance. But judging from what I've seen now, I'm more inclined to want to create more features and see how I can improve the performance of this Lasso regressor than I am to look at random forest. Okay. We could find a way of looking at if the person paying the bill is a male smoker, or not, essentially. And maybe we can get some good features from there. Male smoker on the weekend. What effects would that have? That can be a good way of summarizing everything. So there's a lot that can be done. But yes, it is what it is right now. And yeah, this is how you can do a grid search for a regression problem. Yeah. So I'll see you in the next one, and have a good day.